Did you know that two vehicles have the same amount of momentum between them before a collision and after? It doesn't matter if they're stuck together or bounce apart. Today's lesson is on conservation of momentum. So, the law of conservation of momentum is a law stating that the net force acting on a system is zero. The sum of the momentum before an interaction equals the sum of the momentum after the interaction. So, the total momentum gained by one object is equal to the total momentum lost by one object. So, it is represented by the formula. Uh, the change in P equals the sum of P before equals the sum of P after. So the sum of the momentum before equals the sum of the momentum after. So because this is due to and the momentum formula is mass 1 plus velocity 1 plus mass 2 times velocity 2, we can make the collision formula mass 1 times velocity 1 plus mass 2 times velocity 2 equals mass 1 times velocity after 1 plus mass 2 times velocity after 2. Now, sometimes when I'm writing these equations, I don't like to use the subscripts 1 and 2. I like to use something that's a little bit more descriptive. Like if I have a van and a car, I might use subscripts V and C. So I know that I'm attaching the right mass and velocity to each other. So we're also assuming that the mass of the vehicles doesn't change. So there's no need to distinguish between mass before and after the collision. But velocity does change before and after the collision. So the prime, or that little apostrophe symbol, indicates the velocity after the collision for velocity 1 and 2. There are three different types of collisions. We have hit and rebound, where those objects will bounce back, hit and stick, where they'll be together, and explosions, where we started with one mass and became several afterwards. So in the two vehicles collide and bounce back, often in the opposite direction, we'll be given three of the four velocities. Velocity of object 1 and 2 before, and velocity of 1 and 2 after. So three of those four will be given, and then we'll be asked to find the fourth using this formula. So let's go through example 1. A 3-kilogram ball strikes a stationary ball with a mass of 6 kilograms. The first ball moves at 1.5 meters per second until the collision, but bounces back going 0.5 meters per second. Determine the velocity of the second ball after the collision. So m1 is going to be mass of the moving ball at 3 kilograms. m2 is going to be mass of the stationary ball at 6 kilograms. Velocity 1 of the 3-kilogram ball was 1.5. Speed of the 6-kilogram ball was 0. It was stationary. After the collision, the 3-kilogram ball was at negative 0.5 meters per second, and we're asked to find the velocity of the 6-kilogram ball after the collision. So because the sum of the momentum before equals the sum of the momentum after the collision, we can use our collision equation. And we're going to be looking at finding velocity 2 prime, so the velocity of object 2 after the collision. So to rearrange this equation, we're going to multiply both sides, or we're going to subtract mass 1 times velocity 1 prime from both sides. And then divide both sides by the mass of object 2 to remove it from the velocity 2 prime. So putting in all of our known variables, 3 kilograms times 1.5 meters per second plus 6 kilograms times 0 meters per second, subtracting 3 kilograms times negative 0.5 meters per second divided by 6 kilograms. And this gives us a total velocity of 1.0 meters per second. So that would be in the positive direction on the ball with the mass of 6 kilograms. So in a collision, if two vehicles or objects collide and then travel together as one combined mass, we can simplify our collision equation. So velocity 1 and velocity 2 prime can be simplified just to velocity prime because the two objects are traveling together. So a 1,000 kilogram car is traveling at 12 meters per second when it strikes a 2,000 kilogram truck that stopped at a red light. So it'll have a 0 velocity. After the collision, the two vehicles stick together. What is the speed of the two vehicles after the collision? So the mass of the car is 1,000 kilograms. The mass of the truck is 2,000 kilograms. Speed of the car before the collision, or the velocity, is 12 meters per second. Velocity of the truck is 0 meters per second because it was stopped. We're going to find the velocity of both vehicles after the collision. And again, this is where when I'm writing down my variables, I like to use C's and T's to identify my subscripts so that I know that I'm attaching the right mass and velocity to the right vehicle. So the sum before equals the sum after the collision. Here is our equation. The first thing we're going to do is divide both sides by mass 1 plus mass 2 to isolate the velocity after the collision. And so here would be our work equation. Putting all the numbers in, 1,000 kilograms multiplied by 12 meters per second plus 2,000 kilograms times 0 meters per second divided by 3,000 kilograms, that combined mass of the truck and car, gives us a final velocity of both objects of 4.0 meters per second. So the last type of collision equation is going to be an explosion. And in an explosion, the mass starts as one contained object, mass 1 plus mass 2, and at rest, velocity 1 and 2 is equal to 0 meters per second. After the explosion, the solid object has broken up into two separate masses, 1 and 2, with their own separate momentums. So the formula for explosion is mass 1 and 2 multiplied by velocity 1 and 2 equals mass 1 times velocity 1 prime plus mass 2 times velocity 2 prime. So a 50-gram firecracker is at rest and explodes into two pieces, a 15-gram piece which flies to the right or positive with a velocity of 3.5 meters per second, and a 35-gram piece. Determine the velocity and direction of the 35-gram piece. So our mass of the firecracker is 50 grams. And because our final masses are also in grams, we can leave it in grams. We don't have to convert it. The mass of the first piece is 15 grams. The mass of the second piece is 35 grams. The speed of the firecracker before the collision is 0 meters per second. The velocity of the firecracker after the collision, piece 1, is 3.5 meters per second. The speed of the second piece is what we're going to be determining. Now, just as a note, this will be a negative number, meaning it will fly to the left. So the sum of the momentum before equals the sum of the momentum after collision. Rearranging our formula, we're going to subtract mass 1 v1 from both sides. And then we're going to divide both sides by mass 2. Now we moved in that 0 meters per second there because our velocity of both pieces was 0 meters per second. So just got rid of an extra variable space. So negative mass 1 v1 prime divided by mass 2 is equal to v2 prime. So negative 15 grams times 3.50 meters per second divided by 30 grams gives us a final velocity of 1.5 meters per second to the left. So the piece in the explosion that has a greater mass has a lower velocity after the collision. So I hope you enjoyed today's lesson on the types of collision and conservation of momentum.